Hi everyone, this is Chandan. Today we are going to understand about the memory management and lazy evaluation to optimize our efficiently use of memory and how we can handle a large amount of data using lazy evaluation. Okay, so first we need to understand memory management in Python, how it works. So in Python, we use built-in memory management system to handle memory allocation and deallocation. There is a key components of Python memory management in the lazy evaluation and garbage collectors. So we will see how the memory allocation is used in Python. So Python use a private heap space to store all the objects and data structure. The programmers do not have to direct access to the private heap. So Python use private heap space to store all the objects and data structure, but programmers cannot access and manipulate that memory. And the Python memory manager handle all the allocation of the memory of that objects and data structure. So it is handled by only Python. Let's understand what is garbage collector. So Python employ automatic garbage collection to reclaim memory that is no longer in use. This is done through the reference counting and recycling garbage collection. Basically, Python has inbuilt garbage collection which collect that memory. If that object is not in use, the reference count becomes 0. Means there is no any reference of in our program, so that memory should be deallocated. So that times the garbage collector can't erase that reference counting. Each object keep track of numbers of reference counting point to it. So when the reference count drop to 0, the memory occupied by the object is deallocated. Okay, so reference counting algorithm is keep track of that reference pointing to that object. When the reference count drop to 0, the memory deallocated. Cyclic garbage collection, the use to detect and collect objects that reference each other, preventing memory leak. So it is cyclic garbage collection. So it's detect and collect that object to each others to prevent memory leak. Let's understand what is memory pools. So Python uses a system of memory pools to manage a small object efficiently. This reduces fragmentations and speed up your memory allocation. Let's understand that memory management. So first we need to define one list and we can check that size of, so it will return that size of that list, and when we add that some element to the list and then we check, the size will increase, and when we delete that list, the reference counting will be 0 and deallocated to that memory. What is lazy evaluation? So it is important to understand to efficiently use the memory of programs when we handling a huge amount of data, or optimize the optimization required for handling the huge amount of data in Python. So lazy evaluation is a programming technique where an expression is not evaluated until its value is needed. So it's evaluated only when the value is required in the programs or somewhere actual value is required, then only it is evaluated. This can lead to increased performance and reduce memory usage. So suppose we define some statements and we do not need that actual value that times. So that memory will be used in somewhere else. So and when we required actual use of that value, then that statement will be evaluated. That's why it's called lazy evaluation. Especially when we're dealing large data set or complex computing terms, we are using lazy evaluation. In Python, lazy evaluation is often implemented using generator iterator. So there is a two concept to implement generator and iterator, which is known as a lazy evaluation. So let's understand what is the lazy evaluation benefits, memory efficiency. So only the necessary data is computed and stored in the memory. Whatever the required data at that time in the programs, that data is only stored in that program. Performance improvement, avoid unnecessary computations, especially in large data set. Example of lazy evaluation with generator. So here we define our generators using yield keywords. So a generator that yields number from 0 to n-1. So we provide that lazy range, and there is a range function which generates a number of, and we are yielding that whatever the value is providing by the loop. Using the lazy range generator, we can print one by one. So lazy range, there is a 10 and number. So when we printing numbers are generated one at a one time. So when we print one number, so it won't store that data. So it won't generate all the data in one go. Whatever the required numbers, that numbers only generated in the lazy evaluations and print that. Let's see what is a least comprehension versus generator expression. So in the first statement, we are performing some least comprehension, x into x for x in a range of 10. So actually it's multiply all the numbers 1 to 10 and generate that entire list in the memory. So this type of expression, all the value are stored in the memory. When we perform using generators like lazy evaluation, square generators, x into x for x in range. So that times it does not generate the list, it's only an expression. It just check that syntax at that times, and when we require actual data of that expression, that times the data will be generated. So accessing the value from the generators, so value are generated one at a time. So one value is generated at a time. Let's understand eager versus a lazy evaluation. So when we perform a normal expression, that is a least comprehension or any operation, that is eager evaluation. At the same time, that data will be generated and stored in the memory. But when we perform lazy evaluation like a generator or iterators, that times the expression is only evaluated or compiled, but the data or information is not stored in the memory. So this is the key difference, and we can access that value like that for a square in a square gen and show that value is generated at time. Let's understand our conclusion of that video. So Python management in automatic and efficient. So Python memory management is automatic and efficient. Garbage collection and memory pools enhance performance. Lazy evaluation optimize memory usage and compute time. Understanding this concept is crucial for effective programming in Python. Okay guys, thanks for watching. That's all for today. Thank you.